this is looking at some of the strategies that operators can use to enhance their interconnection, both from a social point of view and also from a technical point of view. Now, one of the questions which has been frequently asked at the last peering forum meetings is, how exactly do you collect and analyze flow data, especially when you are running a large network? Now, a lot of the networks here in Africa have actually been growing over time. So we started from where if you had 4 megs on the entire network as your upstream connection, you felt like you were the largest ISP in the entire country. And that was on satellite. And we went on to having 10 megs, and we were like, whoa, this is way more capacity than I would have ever dreamed of. And we've gone from 1 meg, 4 meg, 10 meg, and now we are buying multiple STM1s, STM4s, STM16, and so on. And now the question is, so how do I actually start analyzing all these data? Because as we saw earlier in the morning, the larger your network becomes, the more traffic you have to analyze. So how do you analyze it if you have multiple STM64s? How do you scale? What do you need to do to make that work? And to help us see how we can actually do that, we have Mark Campbell from Arbor Networks. If you remember, earlier in the morning, we had Martin Levy from Hurricane Electric saying that you could either go open source or you could go with commercial products. Now, he's going to actually present a perspective of how you can actually analyze flow data when you're working on a large network, and how that implicates, or the implications that has, and how you can benefit from that when it comes to peering and interconnection. So without any further ado, I'll invite Mark.
Thank you.
Thank you.
So I have the privilege of having you straight after lunch. So I think I'll entice you. We're running a competition at our booth. And we've got 3 questions on our questionnaire. And I'm going to be covering those throughout my presentation. So if you remember them and give your details on our stand, there's a chance to win an iPad. You just have to fill in information. And I will be covering the answers in the presentation. So it's one way of enticing you to put the food behind you and try to concentrate. I know it's going to be hard for me, but I'll try. So I'm going to be talking about collecting and analyzing flow data for large networks. And then specifically looking at how, once we've got this information, how we can process that and analyze it for peering analysis, and then security on top of that. So I think these should be of interest to most service providers out there today. So just a quick introduction. I'm Mark Campbell, a consulting engineer for this region, Sub-Saharan Africa. Been with Arbor now for 1.5 years, growing from South Africa upwards. So a lot of expansion. Just an introduction to Arbor Networks if you're not familiar with the company. We're over 300 employees strong worldwide, so it's relatively a small company, but it's very specialized in what it does. 90% of the world's tier 1 providers use our products and our solutions, 60% of the tier 2 and 3, so it's very widely used, and we've got very good relationships with these service providers, which helps us augment our products and our information and our databases. So when we look at peering and security, peering obviously can be a major cost to most service providers. You need to do it in an optimal way. There's constant fluctuations and changes in networks and traffic patterns and applications and content that changes the traffic patterns for us. So we need to do it in an intelligent way. When it comes to security, it's very important on our networks to have secure networks. There's very high visibility from management, especially if you look at the kind of press coverage when we see DDoS attacks, hacking attacks, exploiting networks. So these financial costs or brand costs can be quite high, significant when something goes wrong. And we believe Flow is the answer to solving these problems, and I'll go into detail why that is. So Flow uses our investment in routers and switches. We don't have to go and deploy additional software, hardware, probes. We don't have to break the network to get Flow. It's all built into most of our carrier class routers and even enterprise class routers out there today. So valuable information we can get from the current devices that we have in there. And this can help us to report on usage on our network, baselines, and so forth. We can also use that same information to identify threats on our network. So anything that's out of baseline, anything that's anomalous, anything that fits a certain profile, we can then understand and then stop those threats on our network. So flow is prevalent throughout most of our ISP networks. It'll give us a network-wide picture. I mean, you have many appliances you can put on your egress point, ingress point, but you'll only have visibility of what's happening on that one link or that one POP. Now, flow, because it's around the network, can give us a network-wide picture and within context of our traffic flow in near real time and our customers and services and applications on top of it. And like I said before, from a security perspective, it can help us to understand malware, botnets, DDoS attacks, any kind of insider misuse or abuse on our networks, because now we have a tool where we can trace back from a forensic perspective what's been happening in the network. So flow helps us build a model, a baseline in our network. When we combine flow with BGP and SNMP, we have a very powerful tool to help us analyze our network and how it's behaving. We can then detect any abnormality, and as I said before, the forensic data is key, that we can backtrack any kind of exploit later on. So we'll be discussing what flow is for those that aren't aware of it. We'll look at the different versions, what is supported out there. Then we'll look at how we can use this information for peering analysis. We'll look at a few use cases, real-time, that peering coordinators would use from a day-to-day perspective. Then we'll look in security, how we can use flow to understand what threats are against our networks and how we can stop those, and then some use cases around that. So flow, we've had many different versions throughout the years. We're currently sitting at version 9 of Netflow. We have S-Flow, J-Flow, C-Flow, NetStream, IPFX, Flexible Nextflow. So it seems like there's a lot of options, but you must just understand that they're an evolution of each other. And as it expands, we get more feature and functionality out of it. And all the different vendors support their own flavor. Obviously, IPFX is becoming a standard, or it is a standard, which everyone should be moving towards. But most hardware vendors have their own flavor of flow that you need to work with. So flow records within a router, they're kept in a flow cache, which is in the memory of a router. And then when there's a significant event, like a timer that expires or an idle session, these flow records will be exported to a collector. And that collector can then analyze the information and do reporting for you. And we'll look at some examples of how that could work. So a flow record is unidirectional by nature. So when you have a conversation between two hosts, you'll end up most probably with 2 records or more, because that's for the bidirectional conversation. So you need to have a way of getting all this flow information and putting it together so you understand conversations rather than unidirectional flows. Now, if you look at Netflow version 5, which has been very popular up until a couple of years ago, Netflow version 9 is getting a lot more traction, and we'll see why. We've got a couple of key fields and some non-key fields. I believe this was covered a bit earlier, so I'm not going to go into detail. But we have a lot of information, source, destination, IP, ports, protocols, TCP flags, and so forth, packet count, AS numbering, prefixes that we can get from the Netflow version 5 record. So how this works, once again, is you have a conversation. You can see we have 2 hosts talking to a destination IP address, multiple protocols, so UDP, TCP. We can see the flags, we can see the packets, and so forth. Now, this is all kept within the router's Netflow cache. And then when there's some timer that expires, this gets exported to an external collector device, a collection device that you can have on your network. So some level of aggregation that happens through these steps. And then important to note is that Netflow is transported across the network using UDP. So it's an unreliable transport mechanism. So things like network instability might cause us to lose some flow records, and we'll see just now how we get around that. I keep on hitting this button. So Netflow version 9 gives us some additional fields. And Netflow version 9 is important for us so that we can get flow export for IPv6, MPLS, and multicast. And we all want that information, so it makes sense for us to move to Netflow version 9 on our networks. Now, Netflow version 9, excuse me, gives us the ability to have templates and data flow sets that link to those templates. Give me 1 second, sorry. Gave you some time to absorb that slide. So you can have, for instance, a template for a specific interface, so you can really configure it down to what you want to see on that router. So you can have multiple templates per router and see specific information on different interfaces. And this really comes down to using your resources most effectively, because you don't want to just export everything all the time, because that's not what you might be interested in seeing. So you want to be able to configure it, and that's what Netflow version 9 also gives you, these templates that you can choose these key values that you want to export. Now, on top of Netflow version 9, vendors like Cisco have come out with flexible Netflow, which basically gives you a lot of what Netflow version 9 gives you, but also gives you the ability to add some other fields to it. For instance, if your router does network-based application recognition, NBAR, or you want to get some payloads, you can now get that information in your flexible Netflow packets. So you can do a bit more deeper level analysis, layer 7 analysis from your Netflow information. And we've discussed AfPIF3, which is obviously the standardized vanilla flavor of flow, which most vendors are supporting these days. Now the question, I believe it has come up, do I sample or do I use unsampled flow for my network? Now it really just comes down to what you want to see. So for instance, unsampled flow is useful if you want to troubleshoot, want to have some backtracking forensics, and then obviously you can use it for traffic analysis, anomaly detection, and so forth. Whereas sample net flow isn't necessarily that great if you want to troubleshoot and do some forensics, because you might miss a couple of packets in the conversation. But if you look at service provider networks, because of the volume of traffic, that statistical sampling that you get is pretty accurate. I must say, from the networks I've seen where we've got our equipment in, you generally don't miss conversations just because of the volume that you have. If it is, it's negligible. So it really comes down to what you want to see and what your platforms can support, what your collector platforms can support. And you can liken it to a phone bill. I mean, at the end of every month, we don't just get a CD that's got all of our conversations that we had on our phone calls as a way to bill us. We rather have a phone bill that details what conversations we've had, what numbers we've dialed. And that's, you can sort of akin Netflow to that. So you don't want to have necessarily all that information that a wiretap would give you. So where do we listen for flow? What traffic do we record in our flow record? So generally speaking, you want to have it at your ingress-egress points of the network, because that's where you're going to be seeing most of the flow. And that's probably the most expensive part of your network, is your peering, your upstream, your long-haul links, for instance. So it makes a lot of sense to have Netflow switched on at the edge of your network. Then, if you've got maybe a hosting facility, you want to report on the traffic that your hosting customers are using, you can deploy it, you can enable Netflow within your data center, wherever you want visibility, basically. So you switch it on interfaces and routers where you feel you want to see that information and you want to report on it. Now, it's also important to understand that if you've got flow enabled on multiple devices, you're going to see that same flow record multiple times. So you've got to have a way on your collection platform to aggregate that so you can have a single view of that total traffic. And then obviously you want to look per router what it has been passing. So you want to have that flexibility to move the reporting around. Now, when it comes to scale, there's considerations depending on the size of your network. So if you have a small network, or relatively small network, a centralized collection point for flow telemetry and reporting can be fine. We can even look at using unsampled Netflow in that case, because our volumes of traffic might not necessarily be that high that we are compromising the performance of our systems. But when we look at large-scale networks, we obviously have, excuse me, sorry about that. It was that dessert. I shouldn't have had that sweet chocolatey pudding. So when it comes to large-scale networks, we obviously want to now start distributing the flow information. You don't want to transport or backhaul all the flow from your POP in Cape Town to Johannesburg, for instance, or your POP in the UK to Johannesburg. It doesn't make sense. So you want to distribute your collection platforms, but still have a way of centrally managing that and analyzing that data. Otherwise, you'll be running around coding and doing reports for the rest of your life. You want to see if you want to give access to your customers for this information that you have collected on your network. And that also changes the design and deployment a bit. Now, what we recommend is having an out-of-band network for flow information, because like we said before, Netflow is transported across UDP. So an out-of-band network is secure, number one, and it'll give us reliable transport for our NMS applications, so we don't lose information. Then we want to look at the sampling rate and what kind of flow per second our systems can support. That comes down, again, to the sampling rate that you choose for your network. Just to give you a thumbs up, what we generally recommend our customers to do is to start off with a flow sampling rate of 1 in 1,000 packets. That gives us enough accuracy to do reporting and to do anomaly and threat detection. Some of our customers, when they use flow for billing purposes, in that case, we recommend 1 in 1 packet so that you can have far more detailed and forensics traceback for that information. Anything over 3,000, you're going to start losing accuracy. So just to give you a benchmark of the kind of sampling rates that we look at. And that, I mean, most of the vendors I've worked with can definitely support 1 in 1,000, at least. Others need specialized hardware within their routers to support anything lower than that. So that's just something to consider. And talking about billing, once again, you want to look at ways of backup and restore for this information in case of a failure, because now it's becoming a lot more critical for your revenue to keep this information in a reliable place, which is what we see in large-scale networks. And then, obviously, the impact on your infrastructure. These are just some bullet points of considerations. We can go into them in a lot more detail when we have a session with you one-on-one. We can look at your own specific requirements on that. So as it was discussed before, we've got open source tools at our disposal for flow collection and analysis, and there are commercial tools. Now, Arbor is obviously a commercial tool. Benefits to that, less things for you to worry about, less things for you to configure yourself. What we see important in other operators, we can integrate into the product before you even know it's something that you'll find useful. Whereas if it's all up to you, you're going to have to be coding things as and when you need them along the way. As we said before, you've got to think about things like duplicate flow records, distributed nature of flow, how you aggregate that information, over what period you aggregate that information. So just some basics that you need to consider if you do go down the path of doing your own system, which is very plausible. We've got, I've met many customers that do that for a specific purpose. But obviously, you have the choice of what you want to do in that case. So let's look at flow from peering analysis perspective. This is a peering conference after all, so we'll talk about that for a moment. So if we look at the internet, many of us are very familiar with what the internet is. A bunch of AS numbers that are interconnected by means of transits or peering agreements. And all hosts within the internet or on the internet belong to an AS. That's really how it works. And what holds us all together, the glue that holds us all together, is obviously BGP. So within BGP, we have prefix masks that are advertised, next up information, AS path, and community strings, which is a very powerful tool that we can use in architecting our networks with BGP. And it's a very important tool that we can use when we want to report on our network traffic. It helps us to bring down a lot of the admin overhead when network changes happen. So many tools at our disposal within BGP. So just a quick recap. If we look at an AS path, for instance, we have the AS origin at the end of the path. We have a peer upstream, and then we have transit ASNs between the origin and the peer. Now, these are all different angles at which you can look at your traffic flow across the network. So for some reasons, you want to look at origin ASs, other reasons you want to look at transit and peering. So what we have within the Arbor solution is we marry BGP routing table with Netflow or flow information, whatever flavor it comes from the router vendor, with SNMP, and we put those together in the reports that we give you. And I'll show you some practical examples of how this helps you. So this helps you from a peering analysis perspective, because now you can see near real time where your traffic is going to or from the AS origin perspective, from transit, and from your customer's perspective. And you can make educated guesses or educated policies to go and give to your net ops guys to go and implement something deterministically on your network. Instead of just going, well, I think if we move this prefix or this AS, this might happen, and let's see when we implement that tonight. So you can really look at what is happening now, and if you had to implement a change, what effect that would have. Then using BGP routing table, obviously, like we said, allows us to dynamically adapt to network changes. So if you use your own flow tool that you've developed in-house, when there's a new prefix being advertised from a peer, from a customer, from an upstream, you have to add that in all the time, unless you've got a dynamic way of doing that, to keep the reporting accurate. Sorry, this presentation for some reason is flicking through by itself, so excuse me when I go back a slide. So obviously we discussed peering and transit. So from a peering perspective, when we associate the AS path information, IP prefixes, and the flow information we get from the traffic on the network, we can learn how much traffic is going to or from an autonomous system, which BGP peer we are using to get to that autonomous system, which transit ASs we are using to get there. Are they using that same transit to come back to us, or are we doing some asynchronous routing on the internet? And what kind of traffic is it? Is it something we could offload to our content distribution system? Is it something that we can offload to our in-house DNS servers or mail servers or something to that effect to take some traffic off? So these are all bits of information that could be useful for peering analysis. From a transit provider's perspective, we want to understand when traffic comes in a certain interface, where's it going? If it's going to a customer, to a peer. If the network lands on our network, we don't just want to transport it anywhere it wants to go. We want to make sure we understand why it is going where it's going and see if we can maybe optimize our network for that. So from the perspective of a transit provider, it really comes down to network planning and network evolution, really understanding the nature of the traffic on your network. And this is also what you can get from marrying BGP with flow information. And we'll look into some examples. So just to give you, this is just a very simple screenshot. For instance, we've gone and said, for today, on this interface, the 10 gig interface, where, from an AS origin perspective, where is my traffic going? So you can see we've got this interface in and out. This is our backbone, the remote AS, another AS, a transit AS, and then the origin AS. Now we want to see when traffic is flowing through my network, where is it going? And this is the report we've pulled here. So a lot of it is within our own AS because it's null, right? Apart from that, it goes to AT&T, OCC, and so forth. So now you've got information at your disposal to go and target these providers or these guys directly to maybe, instead of transiting through another AS, you can get them directly on your network. So this is based on real-time information or real traffic information on your network. It's an educated report. So let's look at some other use cases. So my job as a peering coordinator, I need to try to save my company money on transit. This is one of my main tasks. Otherwise, I don't get my bonus. I want to make sure my transit providers that I'm using today are reliable. Should I be using them? Should I look at anyone else? Because I've got tons of other guys knocking on my door. I want to enter peering relationship with other ASNs that make sense. Now, do I do that because I like the salesperson, or do I do it because of the information that's available to me? And then, obviously, when there's some asynchronous routing or some suboptimal routing on my network, I want to give a policy to my network guys to implement to change it and to make it more optimal. So for this week, I've got myself a good couple of tasks assigned. So firstly, I want to see an ASN on my network that I could negotiate a settlement-free peering agreement with. That's one of the things I want to do because that's going to save some money. I want to try and find an AS that I could take off one of my transit providers. So I want to have a direct peering with this guy instead of paying my transit provider a lot of money for that. So saving money once again. Then I want to look at the stability of my top 5 peers or transit providers. Then I have multiple links to Cogent. I want to try to find the one that's the most saturated. And then when I find that one, I want to try to take traffic off it and spread my load a little bit more equally so it's more optimal routing, because I've been getting some complaints on congestion on my Cogent links. So firstly, my first task I set out for myself, I want to try and find a new peer for my network, because settlement-free is obviously good for the bottom line, so I need to find a peer where we're exchanging equal amounts of traffic. So when I find this peer, I want to make sure if the volume of traffic justifies it. So I mean, if we're transporting a couple of kilobits per second between ourselves, it's unnecessary to have that settlement-free peering, obviously. If I did move that peer off my current transit provider, is there going to be a cost implication to me? Are there certain brackets, that certain tiers that I qualify for traffic volume? Is it good for me to peer with that guy directly, or should I peer onwards with some of his customers? Maybe that's more optimal. These are all kind of things that I need to ask myself. So within the Arbor Peakflow solution, we have this peering evaluation sheet. So we can choose a period to say for today, for this week, up to 3 years, to see what kind of traffic has been flowing. So when I look down the list, I can see these are all the ASNs that my traffic is going to and from for today. Then I can see how much traffic is going into their network and how much traffic I'm drawing from their network, or how much traffic they're sending me. So obviously, to find a settlement-free peer, I want to find one where it's pretty equal. So if I look down the list, very quickly I see down here, sorry about that, I see here I'm sending about 87 megabits per second, and I'm getting about 100 megabits per second from this AS4134, which is ChinaNet. So looks like a good candidate, so let's investigate that guy. And again, we've got this information from BGP and flow information that we've correlated on the network. So when I click on that AS, I see that the majority of my traffic to that AS is transiting via Internet2 and AT&T on that side. So obviously, if I peer directly with this ChinaNet, I'm going to take traffic off Internet2. So I need to see if that's a good idea or not. But they very simply, I've seen now that that's a possibility. But now, so this AS4134. But now, does it make sense for me to peer just with ChinaNet, or maybe there's something beyond ChinaNet which makes a lot more sense for me to peer with? So if I click on the ChinaNet AS number in this report versus AS path, so I can see through Internet2 to ChinaNet, which is the next AS in the path, that is where majority of my traffic is being split equally. So 42 in, 50 out. And if I look at their peers onwards, it doesn't really make sense for me to approach any of these other AS numbers beyond ChinaNet. So yes, it would make a good settlement-free peering partner for me to approach. Another view that we have within the system is AS Explorer. So what this shows us is your autonomous system is the circle in the middle. The next circle out are the peers that you've got direct peering agreements with. So you've got direct links with them, direct peering setup. Circle beyond that is you're transiting them to get to those ASs beyond them. So this is just another view that I could use to see who I could peer with. So if I look at Global Exchange over there, GBLX, if I hover over the little icon, and by the way, the size of these blocks and the color of the links show me the volume of traffic that we're exchanging between our ASs. So you can very quickly see where the majority of my traffic is going. So I want to look at this guy, GBLX. I see 50 megabits per second in, 40 megabits per second out. That could make a good peering, settlement-free peer for me to use. So once again, I want to make sure, should I peer with them, or maybe someone inside their network is just using them as a transit to get to me, and vice versa. So if I click on that little icon, now their AS number, 3549 GPLX, is the center point of my AS Explorer view, and I can see that the traffic is pretty evenly distributed amongst their peers and amongst their customers. So yes, it would make sense to peer with GPLX directly and not anybody beyond their network. And that would save me about 50 megabits per second of bandwidth on, where is that traffic going? Okay. Can't exactly see, but over here you'll see the AS that my traffic is going through. There's another one, looks like CNest is what I'm transiting to get there. So just a nice visual representation for a quick management meeting Monday morning. What should we do? Pull this up and you can get the information at your fingertips. So now AT&T is costing me a lot of money. This is my second task for the week. I want to see if I can take some of the transit costs off that. So I want to see which peers I'm getting traffic or am exchanging traffic with across the AT&T link. So very simply, I choose AT&T as my peer, and I can see that level 3 is the guy where I'm exchanging, so about 500 megabits per second total in and out across AT&T. So I could take level 3 traffic off AT&T and peer with them directly, maybe save some money on my transit costs. Very quickly, very simple to see that. Now obviously, I've got a couple of peers and transit providers. Are they stable? Are they helping in the stability of my network, the quality of my network? So I want to also look at those to see maybe I should enforce some SLA penalties. So there's a very quick report you can do. You click on Reports Network Peers, and you can look at the paths that you learn from those peers over time. And obviously, when there's big dips, then you know that there's some instability on their routing table and their advertisements to you from a BGP perspective. And if there's big dips on their traffic levels here, it shows that they're an unstable peer, and we might want to talk to them about it or move on to using a different peer as transit. So my fourth task, I want to find Internet2's busiest link on my network. So before I said Cogent, we'll use Internet2 here as an example. So I want to know which interfaces of my network I'm using to get to Internet2's AS number and through them. So very quickly, I choose Internet2. I want to look at the interfaces associated with that. Here I have a list of all the interfaces where traffic is going to or from for Internet2, and I can see the volume. And very quickly, this top one is the one that is carrying the most traffic. So I can definitely go have a look there and see if I can optimize that link in a way so it's not congested anymore. So now obviously I want to take traffic off that busy link because now it's congested. So I go click on that interface itself and I see, okay, so these are the AS numbers that I'm exchanging traffic with across that interface. So I can then go and take Abilene off and pair with them directly. Or I can move them to another Internet2 link, just set my BGP attributes to do such a thing. Or I can be a bit more intelligent and say, which prefix within Abilene should I optimize and maybe send across one of my other links. So I can very easily now go and see this /24. I can maybe move off and move that onto another link with Internet2 and then take congestion off that existing link. So very quick ideas of how we can optimize our network using information we can marry from BGP and Flow. So after a week's worth of work in 1 hour, so it gives me a lot of time. I can attend a peering conference like we are today, so clearly you guys are doing a good job. I could go fishing. So it can save you a lot of time having the proper tools in place to help analyze your network. So from a security perspective, we also feel that Flow gives us a lot of valuable input to understand what is going across our network. So Flow can help us to detect anomalous traffic on our network. Because of things like baseline, we can classify what's going on within context of our network overall. And we can see the kind of services that are running across our network to see if that could be a potential problem to us. So this helps us to do behavioral detection of things like malware, infected devices that have got Trojans or any other kinds of infections on them, and obviously to understand DDoS attacks. So when you look at flow, this is where it's important now to have a network-wide picture of what's going on your network in a distributed fashion, because certain of these malwares and botnets act in a certain way that you can only pick up from the behavior across your network and not just from a single point in a link. So we're going to collate this information and investigate it. So there's a couple of papers here that I've got in the presentation that you can go have a look at where you can use flow for security applications. So they make for interesting reading. It can give you, if you've got your own in-house flow tools that you're using, it can give you some ideas of how you can configure them so that you can understand security threats and problems on your network. But you're welcome to look at these afterwards. But we'll look at some simple examples. So let's look at some use cases. Firstly, on how we can detect bots on our network based on getting flow information. So firstly, malware. It's malicious software. Now, when these call back to, if they call home, they've called to a control and command and control server to wait for instructions, that's when they get classified as being botnets. So based on behavioral analysis or known behavior, we can identify threats on our network from the information we get from flow. So here we have a typical network. So we've got DNS servers and SMTP servers sitting here, and we expect our users to use them. I mean, what's the point of having them there? And then those servers would go talk out to the internet. That's what we try to do in most service provider networks. But what if all of a sudden we see this host A is now making SMTP connections directly to mail servers outside of our network? So, okay, it's something dodgy going on there, but it's not necessarily to say that there's a compromise. But what if that same host had to now go and do some DNS queries to the root servers and not our own DNS servers? Now, those two things together give us a behavior to show that there's something wrong with this host and there's a possible infection on the go there. When host B, for instance, goes and scans a whole bunch of IP addresses, which is not normal behavior, and we can, from flow forensic information, see when this kind of thing happens, we can start picking up on a trend here. So firstly, he's doing scan to multiple IP addresses, which he doesn't normally do, because we've got a baseline from before. So we're suspecting there's some scanning going on from host B. And now we're seeing large volumes of data outbound from this host B, and we could maybe pick up it's a TCP SYN flood, a ICMP flood, a UDP flood. Putting those two together from a behavior perspective can definitely tell us that there's a possible compromise on that host, and we can go block them, clean them, or sort them out. So just some quick examples of how we can look at behavioral patterns within flow information to understand network security. Here's an example. It's not graphical, but to show you if you use the NFDump tool, for instance. So what we're doing here is we're doing a query to say if anything within this subnet is sending anything larger than 20 megabytes of data out of our network, it might mean that somebody's leaking internal documentation external. And then we can very easily see who that host could be, and we can go and target that and sort it out. When we have long-lived flows, for instance, to external hosts, this could indicate that there's some level of key logging going on, that there's some command and control connections that are on the go. And you need to understand how these exploits work to know what to go look for. And this is where a commercial tool like Arbor does help, because it's all updated frequently to give you these kind of fingerprints, as we call them. So when it comes to command and control servers, they obviously control botnet armies, and botnet armies can be hundreds of thousands of hosts big, and they just wait for an instruction to attack a certain destination. So they are pretty well known, and we do pick up on the new ones all the time. So if you could get a list of command and control IP addresses, which would be static IP addresses somewhere in the net, you can then go and run that list against your Netflow information to see who's been talking to those hosts, to know that they've been infected by some botnet. And you can go and look at that. So within the Peakflow solution, we've got multiple reports and screen that can drill down into these kind of security threats and anomalies on your network so that you can attend to them. Because I mean, a lot of them just waste bandwidth and eat up resources. So DDoS. So DDoS is obviously a risk on major networks. We see this growing. We do trend this, and every year the DDoS threat is growing. And a DDoS, or a denial of service attack, and even a distributed denial of service attack, is just a way of exploiting finite resources, if it's bandwidth, compute resources, state tables, or anything to that effect. So this basically stops that system from working and stops the service from being available. And guess what? We could pick up on DDoS attacks using flow information as well, by looking at baseline detection. So for instance, when our baseline says that we see X amount of UDP or TCP information at this rate from these countries to these hosts, and all of a sudden there's a spike, we know that that's out of baseline and we need to investigate that. That could be a potential DDoS attack, and we can then go look into that. We have well-known floods, so we understand if there's if we're seeing a lot more TCP SYN packets and we're seeing ACK packets coming back, we know that's most probably a TCP SYN attack, a SYN flood that's going on. RCMP floods and DNS floods we can pick up in the same way. So these match certain well-known misuse triggers that we could run against the flow database once again to see what is going on. And then, like we said before, when it matches a certain bunch of behaviors, certain steps, if it's doing this, then that, and then this thing, we know it's most probably some anomalous behavior, a well-known botnet malware or something that we can go and track down before it brings down our network. A very simple way of identifying DDoS attacks is to look at your graphs, because they're mostly volumetric based. So when you see this spike all of a sudden, and I'm sure many of you have seen this spike, the next day you get to the office, you think, oh, what happened, whatever, it's not a problem anymore. But it could very well have been a DDoS attack through or on your network. So that could be a trigger to look into more detail, to look at that specific traffic, where it's coming from, where it's going to go and block it and to go clean it. And this is where Arbor has got a solution called the Threat Management System, the TMS, to go and surgically mitigate these kind of attacks on your network. So instead of just black holing the route, creating an ACL, which ultimately completes the attack, because now you're blocking all access to that end host anyway, you can rather clean off the attack traffic and let through the service to that end host, because that's ultimately what your customer's paying you for. So that's the TMS. I'm just giving you a hint for a certain questionnaire to win a prize. So within the Peakflow solution, we've got all these reports. So for instance, here we've detected a UDP flood going on. We can tell you the parameters around that. We can tell you which country it's most probably coming from. So you can then do whatever you want with that information to block. So for instance, if you've got a banking customer on your network, which you expect to see 90% of the traffic must come from South Africa, and all of a sudden there's a huge chunk of traffic coming from China, that is an anomaly against your baseline, and you can go and mitigate that very easily. So it's just a simple use case, but you can glean that information from the alerts that the Peakflow system gives you. Right, so I'll end it there. Any questions? Any thoughts? Sylvia? So sorry, I don't want to say goodbye yet. The Arbor system basically works on a flow per second rate. So we can handle 50,000 flows per second per appliance. So that's sort of our baseline to say, I mean, you can go from 50,000 to 100,000 in a peak or within a spike. But we mostly say that is the limit of flows that we support per appliance. If you need more, you just add appliances to the solution. So it just comes down to understanding the limitations or the engineering limitations that are set out there. From a router perspective, yes, I have seen bugs on routers. I mean, they shouldn't, but Netflow or Flow has brought down certain of the router platforms and then they just have to upgrade the software to one where it's fixed, and then it's okay. If it's a hardware-based platform, obviously a software-based platform, Netflow will have, or Flow will have an effect from a resource perspective from CPU and so forth. But the mostly, and then again, if it is causing a problem in the box, you can bring down the sampling rate or switch off some of those fields that you don't necessarily need to report on. So there are mechanisms to work around that. Does that answer the question? Excellent. Anything more? So if there's nothing else, we'd like to invite you to visit us. We've got a stand. We'll be there and ask us any questions. And yeah, enter the competition. I won't give you the answers now, but we did cover them. And yeah, thanks for your time.
Okay, thank you very much, Mark.